today, but I thought that if you saw a video with me, it would be like I'm here with you. So today we're going to talk about revenue problems. On your final, you will definitely have a revenue problem on there, and so I wanted to make this video. You can play it as many times as you want, you can pause it, you can do all sorts of things, but don't make a meme of me. And if you do, don't post it on the internet, because I would be so devastated if I went on and there was a meme of me on the internet. So revenue problems. First, we have to break down, what is revenue? Anybody? Anybody? Bryce? Colton? Zeke? I'm sure one of you guys answered it. So, revenue, it might not have been one of you three. Somebody in the class just answered that question. Okay, so what revenue is revenue is the total amount of money that somebody or a company makes. So if you think about a movie theater, they sell popcorn, they sell candy for way too much money, they sell soda, they sell all sorts of things. But most importantly, they sell movie tickets. So last weekend, Wreck-It Ralph Breaks the Internet came on into the theaters, right? And so let's say I wanted to figure out how much revenue Ellensburg, sorry, I live in Ellensburg, so I always have to think about them, Ellensburg movie theater made from selling Wreck-It Ralph tickets. So let's say they sold, I'm sure they sold more than this, let's say they sold 150 tickets. And tickets to a movie in Ellensburg are $9. How do you find the total amount of money that they brought in? So they sold 150 tickets. 150 tickets. And the tickets cost $9. Well, to find the total revenue, how much money they make, this is not profit, this is just the money that they bring in. The total revenue, you do 150 tickets times $9. That's it. That's pretty easy, right? So we could build a formula for this. We could say that revenue equals price or cost, right, times number sold. So revenue equals cost times number sold. Well, now having that equation in mind and thinking about revenue, we can figure out how to solve and maximize and minimize, we don't want to minimize, how to maximize revenue. How can a company bring in the most amount of money? And so the way that we can do that is we'll build a cost equation. And this should have a variable in it. Maybe we are increasing the price to try to make more money. And then we need a number sold equation. And you'll take those two equations and you'll multiply them to each other. So your cost equation, the way that it's going to look, is it's going to have your initial cost. So initial cost plus some amount that you want to increase by X. And this some amount, maybe you want to increase ticket price for a movie theater by $1. And if we increase by $1, we put 1 here. And how many increases can we have? So maybe we want to do $5. So you'd have a 5 here. Maybe you want to do $10. That would be ridiculous to go to a movie for $19. Unless it's like a theater that has food in it, a restaurant theater. I don't know what those are called. Then maybe it's worth it if it includes the food. Anyways, so that's what's going to go there. Numbers sold, well, generally, you're going to have an initial amount sold, but every increase, less people are going to buy. So you're going to subtract whatever amount it's going to decrease by X. You'll take these two equations and you'll multiply them together. And that's how you're going to find the revenue. So let's work on a couple of examples together. Okay, so let's go through an example problem. Office Depot sells TI 84 Plus calculators for $100 each.
Chris Morrison to the main office, please. Chris Morrison to the main office.
In a typical August, right before school starts, Office Depot sells 50,000 of these calculators. They are considering increasing the price. For every $5 price increase, 1,100 fewer calculators will be sold that month. So, define the function that models the total revenue to the company, and then also if the prices may increase by any dollar amount, find the sale price that will maximize revenue. So, as we talked about earlier, to find revenue, we need to find the cost and multiply it by the number that are sold. So we need to write two different equations here. We need to write our cost equation, and then we need to write our equation for the number that are sold, and then we need to multiply those by each other to find the total amount of revenue. So our cost, initially they're $100. But then we're thinking about increasing every $5. So every $5 lets us know that we need to have a variable with that. So from $100, we are possibly increasing by 5. Or maybe we're increasing by 10, or maybe we're increasing by 15. So there's our cost equation. Depending on the number of price increases, this is what the cost of the calculator is going to be. The other equation that we need to make is the number that they're going to sell. And so if we look here, Office Depot sells normally 50,000 of these calculators. So normally they sell 50,000. However, for every $5 increase, they're going to sell 1,100 fewer. So this models the number of calculators they're going to buy in relation to the number of $5 increases. So there are two different equations. Now, just like we talked about before, to find the total amount of money that they're going to make, we need to multiply the cost by the number that they sell. So our revenue is going to be 100 plus 5x times 50,000 minus 1,100x. Now that's an equation. We can FOIL that out, and we can write this in simpler terms. You've got many different ways to FOIL this out. You could just simply FOIL. You could also make a box and multiply it out. You could multiply vertically. Whatever you like best is how you should multiply this out. I know we did a lot of practice with the box in Algebra 2, but we've also FOILed. So I don't know, let's do the box. Let's say we have 100 times 5x, or 100 plus 5x, and then on the side we have 50,000 and negative 1,100x. So to complete this box, we will just multiply 100 times 50,000. Well, I would just add 2 additional zeros to this. So, and if you can't multiply that in your head, you always have your calculator. But 100 times 50,000 is going to be 5 million. 5x times 50,000, well, that's going to be 250,000 x. And again, if you can't multiply that in your head, that's fine. You have your calculator. 100 times negative 1,100, well, we're just going to add the 2 zeros to it, which makes this negative 110,000. And then we're going to multiply these two, and we get negative 5,500x squared. And that is how we multiply these out. So we are going to combine our like terms. So we have 5 million. Combine here. So we're going to have 250,000
100,000 minus 110,000, which gives us 140,000x, and then minus 5,500x squared. There's our equation. If you want to just double check to make sure that you multiplied correctly, you could put both of these into your calculator and make sure that you get the same answer. So let's just practice that because we like to double check ourselves. So I'll go into y equals, and I will put our original, which was 100 plus 5x, that's our cost equation, times our numbers sold equation. And then in the second y equals, I'll put the one that we just solved for, so 5 million plus 140,000, I think I put one too many zeros, minus 5,500x squared. And then if these are exactly the same thing, we know we did it correctly. And so as we look down here, these are exactly the same thing. And so we know we did it correctly. And so that is our equation that models the revenue. So as we move through this, the next question says, if prices may increase by any dollar amount, not just by fives, find the sale price that will maximize the revenue. Well, this equation is quadratic. I know it's quadratic because its highest degree is squared. So how do you find the maximum of a quadratic? Oh, maximum is the vertex. So you could use your calculator and you could scroll up and find that vertex and calculate the maximum that way. Or if you remember back to Algebra 2, the vertex is at negative b over 2a, and then you plug that in. So we have our equation here. A always goes with x squared, b always goes with x, and c is always just that constant. And so I could figure out what the number of price increases is going to be. So x is the number of price increases. We've already talked about that. So x is the number of price increases. So if I do negative b over 2a, well, here's my b. So negative is going to be 140,000 divided by 2 times a is negative 5,500. And I can plug that into my calculator and get a number. Negative 140,000 divided by, I'm going to put my denominator in parentheses so that I multiply it correctly. And so it looks like there's going to be 12.72 increases to get to our maximum. So 12.72 price increases to get to our maximum, which means, well, 12 increases would be $60 increase. And then 0.72 is going to be 0.72 of $5. So we want to find what is the sale price. Oh, well, here's our cost equation. Let's plug this in to our cost equation to get how much we should sell each of these calculators for. So I'm going to say 100 plus 5 times 12.72. 100 plus 5 times 12.72 price increases says that we should sell our calculators for $163.60 to get our maximum revenue. So if we increase the price from $100 each to $163.60 each, we will get the maximum amount of money we can. Okay, let's work through another example because I think the more examples, the better. So this is, again, another one from a previous final. What I would like you to do is actually pause the video here and try to work out this problem on your own. When you've gotten as far as you can or when you're done, go ahead and hit play again. So I'm going to wait just a second, give you time to hit pause. Okay, so in the past year at Silverwood Theme Park, 700,000 one-day general admission passes were purchased at $47 apiece. The park would like to increase the price, but financial analysis have told them that for every $5 price increase, 50,000 less passes will be sold. Define the function that models the total revenue to the park as a function of x, the number of $5 price increases. So, remember what we already know is that to find the total revenue, gotta click my pen. To find the total revenue, it's going to be cost times the number sold. So we need to make two different equations. We need to make an equation for cost, we need to make an equation for number sold, and then we need to multiply them by each other. So our cost equation, well, the cost, they were $47 a piece, and we're considering increasing the price by $5. 5 is going to have an x with it, because it says for every $5. So my cost equation is going to be $47 plus, well, we're going to increase in $5 increments. Now what we know is that normally they sell 700,000 tickets. Well, for every $5 increase, they're going to sell 50,000 less. So number sold is going to start at 700,000, but for every $5 increase, they're going to lose 50,000 customers, or 50,000 tickets. So this is the cost, and this is the number sold. And so to write the revenue equation, we're going to multiply these. 47 plus 5x times 700,000 minus 50,000 x. So at this point, we do have a function that models the total revenue, but we want to get this in standard form. And so to get this in standard form, multiply it in. We're going to FOIL 47 times 700,000. I'm going to take my handy dandy calculator. 47 times 700,000. That's a big number. 329, and it looks like I have 1, 2, 3, 4, 5 zeros. So 32,900,000, and then I'm going to multiply this by negative 50,000. So 47 times negative 50,000, and that's going to be negative 235,000 x. I'm not done foiling yet. Now I'm going to do 5 times 700,000. I probably don't need a calculator for that. So 3,500,000 x and then the last one, 5x times negative 50,000. And again, I probably didn't need a calculator for that. Okay. Combine our like terms. So we have 2,350,000. Oh, that should be a negative. So negative 2,350,000 plus 3,500,000. So there's my middle term, and so here is my equation. Now, if you want to check your work, you can always plug in this one and then plug in this one into y equals. And if you get the same thing, then you know you did it correctly. So 47 plus 5x times 700,000 minus 50,000x. And we want to make sure that that's equivalent to 32,900,000 plus 1,150,000 minus 250,000 squared. So I'm just going to go into my table and I'm going to hope that these are the same numbers, and they are. So I know that I FOILed it out correctly. So this is my equation that models the total revenue. So this is going to tell us how much they're going to make per each $5 increase ticket. So if the prices may increase by any dollar amount, not just 5, find the past price that will maximize the revenue. So we want to find the past price that's going to maximize our revenue. So we have our cost equation here, but we want to maximize our revenue. And so to maximize our revenue, we need to find the vertex of this equation here. So remember, our vertex is negative b over 2a, and then you take that and you plug it in. And that's how you find the maximum. So negative b, well, that's going to be negative 1,100,000, oh, I wrote too many. Negative 1,150,000 divided by 2 times a is always the one that's attached to the x squared, negative 250,000. So I'll put that in my calculator. Negative 1,150,000 divided by, I'm going to put my denominator in parentheses, and I get 2.3. So this is the number of increases that I need, number of $5 increases that I need to maximize my cost. So let's take that and plug it in for our cost equation. 47 plus 5 times 2.3, and that's going to give us the cost. 47 plus 5 times 2.3, and our cost is going to be $58.50. And that is how much they should sell the tickets for to maximize the amount of money that they are going to make.